In this video, I'm going to be defining a proportion, and we're going to talk about different ways that we can write proportions, how we can solve proportions, and then how we can use proportions to solve for some unknown values. So first, what is a proportion? Well, a proportion is when we set two ratios equal to each other, or when we compare two equal ratios. So for instance, 1 to 2 is a ratio. What is that equal to? Well, it's equal to a lot of different other ratios. 3 to 6 is one possible ratio that it's equal to, but we could also say 4 to 8 or 6 to 12. Any ratio that's equal to 1 to 2 would be proportional. Just like when we write ratios in three different forms, we could also write proportions in those same three forms. So we could write it as a fraction. So I have this ratio in fraction form equal to this ratio in fraction form. Or we could do the same thing in word form, and we could say that this ratio in word form is equal to this ratio in word form. And we could do the same thing with colon form. So we could say this ratio in colon form is equal to this ratio in colon form. To solve a proportion, to find one of these unknown values, if we're missing one of those values, we use a method called cross multiplying. So the way that we can cross multiply is to think about multiplying diagonally. So if I want to rewrite this proportion after I cross multiply, I'm just going to look at my two diagonal products here. I could do A times D and then set it equal to the other diagonal multiplication, B times C. And it doesn't matter which of these you multiply. It doesn't matter what order you multiply in, but you're always doing one diagonal product and setting it equal to the other diagonal product. So in this example, I want to solve for D. So I want to take it one more step here. So to solve for D in this equation, I need to divide both sides by A. So by doing that, I'm given the solution, the product of BC divided by A. Let's take a look at proportions in those other two forms. So these are the little trickier because it might be better to visualize proportions in that fraction form if you're going to cross multiply until you get used to the pattern, and then you might be able to just jump straight from this form into your equation to solve. But for a little while, let's set up proportions in fraction form so that we can visualize that cross product. So if I have 3 to 4, I could write that in fraction form. If I have x to 8, I could write that in fraction form. We're setting them equal to each other to set up the proportion, and now cross multiply. So you have 3 times 8 is equal to x times 4. So we could have 4x equals 3 times 8, which is 24. And then solve for x by dividing both sides by 4, and we can find our solution for this missing value is 6. And that's true. If I double this ratio, I do get 6/8. One more example here, using colon form. Again, it looks really messy in that colon form, so rewriting it in the fraction form might help. So I have x plus 3 compared to 6. So let's write that in fraction form. Then I have x minus 2 compared to 4. We can cross multiply. So I'm doing 4 times the quantity x plus 3. So let's make sure we distribute when we multiply. We're multiplying 4 times x and 4 times 3. And then the other diagonal, 6 times the quantity x minus 2. So let's make sure we distribute that 6 to the x and the negative 2. So after distribution, we have 6x minus 12 is equal to 4x plus 12. To solve for x, I'm going to subtract 4x from both sides. I'm going to add 12 to both sides. So that leaves 2x here on the left side and 24 on the right side. To solve, I could divide by 2 and get my solution 12. We could then plug it back in to check our work. 12 plus 3 is 15. So I have 15 over 6. 12 minus 2 is 10. So I have 10 over 4. If we reduce both of those, they should be equal. So 15 over 6 reduces to 5 halves. And 10 fourths also reduces to 5 halves. So we can always check our work when we solve proportions by plugging the value back in and simplifying and making sure that both ratios or both sides of the equal sign are equal. If we can write proportions and we can solve them, we can use them to solve some application problems. So in this example, we know that players on the basketball team make 3 out of 5 shots on average. After a game where they took 74 shots, how many did they make? Well, we're going to use our first ratio. We know that we can make 3 out of 5, so we can set up a ratio comparing how many shots we take, how many shots we made to how many shots we take. And then make sure that we set up the next proportion so that corresponding things are in the same spot. So on top, I put how many shots we made. On the bottom, I put how many shots we take. So in my next ratio, I need to match that. On top, I'm looking for how many shots we made when we took 74 shots. So shots being taken are on the bottom, shots being made are on the top. We got to make sure and keep those corresponding values in the same spot in our ratio. So now when I cross multiply, I'm doing 3 times 74, which is 222. And then setting it equal to this other diagonal product here, 5 times x. To solve for x, I can divide both sides by 5. And I get 44.4-ish. I want to round to the nearest whole shot, so I could round that down to 44. So if our team is taking 74 shots in a game and we keep this same average, we can expect to make 44 of those shots. One more example here. In this example, we just entered a cheeseburger eating contest. During this contest, we ate a cheeseburger every 15 minutes. And we want to find out how many cheeseburgers did we eat in the first 3 hours of the contest. Well, let's make sure and use units that are the same. So if we're talking about minutes and hours, let's make sure we convert them both to the same units. It doesn't matter which. I'm going to choose to convert them to minutes. So I'm saying that I ate 1 cheeseburger in 15 minutes. That's my first ratio. And want to figure out how many cheeseburgers I ate in 3 hours. Well, there's 60 minutes in an hour, so there must be 180 minutes in 3 hours. So now that I got the same units, I can solve my proportion. So we're going to do 1 times 180 equals 15 times x. And to solve, we would divide both sides by 15 and find out that x is 12. So we must have ate 12 cheeseburgers in 3 hours. And that makes sense. If we're eating a cheeseburger every 15 minutes, that means we're eating 2 every 30 minutes or 4 every 60 minutes. So 4 in 1 hour, we must have 12 in 3 hours.